Hello students, this is Shailaja Vibhute. In the last video, we have discussed about electron emission, types of electron emission, photoelectric effect, observations made by Hertz and Lenard. Today, let us begin with observations made by Hallwach. Hallwach used gold leaf electroscope and zinc plate. Gold leaf electroscopy is used to detect charge on the body, and zinc plate consists of both positive and negative charges. Hallwach observed that when the negatively charged zinc plate was illuminated by ultraviolet light, it loses its charge. Negatively charged means it consists of only negative charges. So when negatively charged zinc plate was illuminated by ultraviolet light, it loses its charge. Say if zinc plate was uncharged, means consists of both charges, when it was exposed to ultraviolet radiation, it became positively charged, means loses electrons. Positively charged zinc plate was found to be further enhanced. So from these observations, he concluded that negatively charged particles were ejected out from zinc plate under the action of ultraviolet radiation. Lenard and Hallwach studied the variation of photoelectric current with collector plate potential, frequency, and intensity of incident light. So we completed observations made by Hertz, Lenard and Hallwach. So you can expect a question here. Explain the observations made by Lenard and Hallwach. Let us move on to next one. Experimental study of photoelectric effect. See this figure. First we will see experimental setup. The apparatus consists of an evacuated glass tube. The side tube is fitted with the quartz window. S is source of light, and inside the evacuated glass tube, C, that is photosensitive plate coated with photosensitive material, and A, that is collector plate. You are observing positive and negative sign there. It is called battery. It is used to maintain the potential difference between the plates C and A and can be varied. Mu A is micro emitter used to measure photo current. Respective potential can be measured by V voltmeter. Commutator is used to change the direction of current. Now let us see the working. When light from source passes through quartz window, which permits ultraviolet radiation to pass through, and when it falls on photosensitive plate C, it emits photoelectrons. The photoelectrons are emitted from C and are collected by A. Then micrometer measures photoelectric current. And voltmeter measures potential difference between C and A. Now based on this, we will see experimental observations. These are called experimental results or laws of photoelectric effect. Let us see one by one. First one, it is an instantaneous process. Means the emission starts in a time of the order of 10 raised to minus 9 second or less. So when radiation falls on metal surface, immediately electrons are ejected. So it is an instantaneous process. For a given material, photoemission takes place above certain minimum frequency of incident radiation. It is called threshold frequency. So photoemission takes place above threshold frequency. Now see the next one. Above threshold frequency, photoelectric current is directly proportional to intensity of incident radiation. Observe the first graph. Along x-axis, intensity of incident radiation is taken, and along y-axis, photoelectric current. Since photoelectric current is directly proportional to intensity, it is a straight line which passes through origin. Now see the next result. Above threshold frequency, the maximum kinetic energy of photoelectrons is directly proportional to the frequency of incident radiation. Now observe this second graph. Along x-axis, frequency. Along y-axis, maximum kinetic energy. If you observe the graph, it has not started from origin, because above threshold frequency, the maximum kinetic energy increases linearly with the frequency of incident radiation. Photoelectric current just becomes zero at a particular negative voltage. It is called stopping potential. Now let us see what is this stopping potential. It is the minimum negative potential given to the anode at which photoelectric current becomes zero. Here one more definition you can see, that is for saturation current. It is the maximum value of photoelectric current for the fixed frequency and fixed intensity of radiation. Here you are observing two more graphs. In the third graph, for a given frequency of incident radiation, the photoelectric current increases up to certain applied voltage and remains constant, that is saturation current. For radiation of higher intensity, photoelectric current increases in the same manner but to the greater extent as shown. But stopping potential is same for all intensities of same radiation. So important point here. Stopping potential is independent of intensity of incident radiation. In the last graph, It is found that stopping potential increases with increase in frequency of incident radiation. So here you can expect the question, write the experimental results of photoelectric effect. Now let us come to the next one, most important one, Einstein's explanation of photoelectric effect. According to Einstein, light consists of photons. When light of suitable frequency falls on a metal surface, the photons interact with the matter and one electron is emitted due to one photon. So, when you are considering incident light as a photon, its energy is taken as E is equal to h nu. H is Planck's constant, nu is frequency. When a photon falls on metal surface, the electron completely absorbs the photon energy. This energy is used for two purposes. Part of the energy is used to just emit the electron from metal surface. It is equal to work function. Hope you remember work function W. The remaining part of the energy is used to provide kinetic energy to the emitted electron. So see in the figure, incident light E is equal to h nu falls on the metal. Then one photoelectron is shown, part of the energy is used for work function. Then remaining part is used for the kinetic energy for the photoelectron, and it becomes photoelectric current. So very simple explanation made by Einstein. Now if we want to write in the form of equation, according to law of conservation of energy, total energy given is equal to work function plus kinetic energy. That is E is equal to W plus KE, or kinetic energy KE is equal to E minus W. But E is equal to h nu and work function W is equal to h nu naught. So if we substitute these two, we get kinetic energy is equal to h nu minus h nu naught. This is called Einstein's photoelectric equation. Here h is Planck's constant, nu is frequency of incident radiation, and nu naught is threshold frequency. So what is Einstein's photoelectric equation? Kinetic energy is equal to h nu minus h nu naught. Hope you have understood all these. To practice these, again here some question answers are given. First one is, mention the types of electron emission. Second one, what is photoelectric effect? Then third one, define work function, threshold frequency, 1 electron volt, and stopping potential. So practice all these. Let us continue in the next class. Thank you.